How's everyone doing? How's everyone doing? All right, now I got to boop. All right, well, thank you everyone for joining this session. Thank you and everyone on the live stream. My name is Nikhil, and we're going to be talking about testing in the cloud. Mobile testing, how can you leverage the cloud in your day-to-day cycle, but we're going to be focusing more on general testing across the board. So feel free to, if you have any questions for mobile testing in general, cloud, just feel free to stop me at any point. Before I start, how many people in the room have developed their own app? Anyone? All right, one person. Dennis, you have an app. All right. How many people have attempted maybe writing an app? Maybe an Hello World app? All right, more hands, more hands. How many people want to write an app? All right, now the hands are coming up. How many people have done some form of testing at some point? All right, now we got the majority hands up. So, before we start today, if you want to work with me, so what I'm going to do is I'm going to start with just general testing. If you've never written a mobile testing app, we're going to do that today. So what I'm going to do is we're going to use one of the testing frameworks, a really easy one, and this is not just a sample Hello World app or anything. What you could do is, whatever we do this in the session today, you could actually use it for your production level apps or even your app that you're planning to deploy on App Store. So you can use the same practices. It's just one of the testing frameworks that we'll use, Instrumentation or Espresso. So if you want to work with me, all you need is Android Studio, and there's the GitHub link. So you just have to download a sample Android app because you need the app to work with me if you want to. So if you just go to GitHub, search for AWS Device Farm and Android, it's the first link that shows up, or just go to that URL. All right. Now, how many times has it happened as a user that you got all excited about an app? Maybe you were browsing something, you read a tech article, or if your friend told me, hey, there's this great app, have you seen this app? And suddenly you say, well, yeah, that's what I was looking for. It will like maybe schedule my day, maybe do some financial advice for me. And you get all excited, you go in, maybe Facebook or some other thing, social media showed you an ad. It's like, oh yeah, that seems interesting. Maybe this is, out of the 1,000 ads that I see, this is worthwhile. And you go in, you download this app, and then suddenly, in the first 30 seconds, something doesn't work as expected, right? Maybe the login froze, or you logged in, you created an account, and that didn't go through. Or it said, oh, give me like this code, and like I'm not gonna open my email. So there's this experience, right? So if you don't get the good experience in the first few seconds or the first few minutes that you download an app, you're probably going to delete it. And if you had high expectations, that's what's going to end up happening. So you go to the App Store, you go to the Play Store, and you start reading reviews like this. Well, it used to work. I don't know what happened. I got this latest and greatest device. I don't think hardware is the problem. So what's happening here? Or, well, it used to work, but suddenly, the network changed or some interface changed and I installed some other app, maybe that's what's doing it. All kind of theories goes on. So as a user, you can imagine the frustration. Think of it from a developer's perspective. What is he thinking? The developer's thinking, well, I can see the App Store reviews. I think I know what might be happening. So he says, well, let's look at the reviews. One of them says, the device, a particular device isn't functioning as expected. The other one says, well, the app used to be great, but something changed. So maybe an updated version of a device got released, and on that it doesn't work. So what does the developer do? Well, I can fix this, right? He's a smart person. He says, let me just go and buy the devices that's showing the problem. I know, because I may have tested it not on all devices. I have few devices lying around. I need more devices. Or maybe I just test it only on emulators or simulators, Maybe I need to test it on a real device for this particular condition. So he starts on this journey of getting these devices and says, okay, I'm gonna maybe set up my own lab, small lab. Do you guys see any problem with this kind of an approach? Like if you were to start and do this lab of your own, do you see any obvious problems? Sorry, what? Too many lights? Yes, too many devices, too many wires, right? Any other issues that you see? Sorry, what were you saying? It's not scalable. Today this image has 8 devices. What if you want The 80% US market coverage, is 8 devices enough? That's one of the questions. Maybe, and as time grows, in 1 year, every manufacturer releases their flagship phones. How much are you going to scale in that case, right? Any other? Software version, that's a good point. If, let's say that iPad is today on iOS 12, 12.1 goes release, and you have only one iPad, maybe what if it's an expensive iPad? Once you go forward in iOS, then you're like, oh, I needed 12 to test a bug. How do I go back? Android, maybe it's possible. iOS, it's really a one-way street, right? What other things do you think? You have to be a specialist, yeah. Yeah, it's a specialized whole operation, right? Because you're going to figure out the power and this OS update and all of that. Time-consuming, cost. When you start building and expanding and scaling, how are you going to manage 80 or 100 devices, for example? And cost. How many devices are you going to end up buying? What other things? You cannot automate, it's a challenge. How do you build a solution that you might be able to automate this solution? Because if you say, well, let's say you're a smart person, you figured out 50 devices all connected to a big USB hub. It's like, okay, good. Let me start running this test now. And you're like, okay, ADB devices, and you see 50 devices. Firstly, is that host machine even going to show all the 50 devices? First question, is it strong enough? And then, how do I deploy it on all these devices? How is this going to work, right? So there's a lot of problems on the surface. If you start scratching and looking at individual problems, like you brought up a really good point about automation. But what if you just want to reproduce a problem? Let's say you exactly know what produces the issue. You just want the device for a few minutes. You just want to plug in, reproduce the problem, look at it. What are you going to do? Walk to the lab? Or how do we get access to that particular device? So there are plenty of challenges in mobile testing space, right? So one gentleman brought a good point about the OS versions, right? So fragmentation of devices. There are so many manufacturer, make, carriers out there, and everybody is releasing at least one device a year as an average. Every time the devices has new hardware, new software, every manufacturer puts their own custom image as far as Android goes, or at least we don't see vanilla Android throughout the ecosystem. iOS is not really so much affected by the fragmentation problem when it comes to the OS level, but it is still, if you see the past 2-3 years, they've had so many types of devices now, so it's different device resolutions, different interactions. Then, let's say you solve that problem. You said, okay, I know what percentage of device I need to target, and this is good enough for me. Let's say you started with that point. You need reliable access. Gentleman here said, how do you access them for automation testing? Or maybe you want to do remote access. You just need to figure out these access for all your use cases. Then let's say you figured that out. You say, okay, I'll embark this journey of writing UI automation tests. Now you say, well, what kind of test do I need for my app? Do I need functional test? Do I need stress test? Do I need unit test? Do I need UI test? Is there a sweet spot? Can I just write one and that will do everything? So that's a challenge when you say, well, I am going to write automation for my app. Like, what kind of testing framework do you use? If you just do a Google search, say, mobile testing framework, you'll find at least 20 different names, and everyone claiming to be, well, yeah, no, this is the one. It solves all the problem, and pros and cons and all of that. It's easy to get overwhelmed. I get overwhelmed with just, what color of phone do I want to buy? Forget the testing framework. So it's easy to just get lost in that. Let's say you figured and just went with the default one, saying, okay, this seems okay to me. I'll go with one of those. Now, you want to have not only write tests, but have these tests be running on a daily basis, nightly basis, or at least on demand, right? So it's no use that you write one big test suite with, say, 1,000 tests. You want to have a predictable thing that if you change a line of code, you need to have an end-to-end system, a continuous integration system that will run these automated tests for you. But then the challenge comes, do you run this on real devices? And if you do, how do you get all those real devices available on that continuous, so the CI/CD system? Because if normal software, you change anything, it's pretty seamless, builds everything, tests everything, but how does it work for mobile devices? Then, the next point is reporting. So let's say you figured out the continuous integration. If you had 1,000 tests, imagine one test produces 5 different types of log artifacts, your device logs. Just imagine, like, one test failed, you have to go in and dig into the logs and just do so much searching. So you need actionable reports, like, okay, test number 500 failed, I want to go there and find just the relevant part. Just don't show me all the, the whole jungle of things going on. So the next thing is the access to test artifacts. So what I said about reporting, if you do find, if the reports just point out that, hey, something's going wrong here, you just need access to the relevant artifacts. You don't need like the whole thing. You're not gonna download 1 gigabyte of data if your, let's say, app produces a large file. You just need the relevant artifacts saying, okay, that's what's relevant for me to fix the bug. And in all this picture, goes without saying that you need granular control of those devices. Let's say your particular test framework requires you to have a particular setting on the device to be persisted, or your app needs maybe GPS turned on or GPS turned off, or Wi-Fi turned off at a certain point. So you need to make sure that you can have this granular control on certain set of devices that you're running on. And the same applies to your test setup. What if you want to run just 5 tests out of those 1,000? You don't really want to do a manual separation of those tests. You just say, run those just 5 tests. So how does Device Farm come into picture? So Device Farm, as the name suggests, is a farm of real devices. It's an app testing service that hosts real devices in the AWS cloud. These devices are real devices. They are not emulators. They are not simulators. They're not virtual devices. They're not tampered on a hardware, software level, or network level. What the experience is that a customer, someone who's using your app, how is he going to use the device? They go into a store, buy a device, download your app, and that's the experience that Device Farm aims to provide you when you run your tests, that these devices are not tampered in any way. They're isolated from each other. So we have over 400 types of unique devices. All these devices are isolated from each other on a network, hardware, and software level. So when I say hardware, software, and network, that means device A is not able to access the network on which device B is connected. Every device has their dedicated network. And hardware, when your device and your tests are running, there's nothing that, oh, one device is playing something and some other device is listening on it, or someone's watching the device. So they're completely isolated. And on a software level, they don't have a shared stack, because when a device is running, every device gets its own individual host machine for that period of the run. So there's really no sharing of state, data, context, anything whatsoever. So how do you use these devices, right? Let's just talk about general, keeping Device Farm aside for a second. You need devices for automation. What can you possibly do with these devices? You can either run automation testing, or you can do remote access, right? Those are the only 2 use cases that come to mind right away. And automation testing can include your performance test, your normal UI test, your functional test. And your remote access is essentially, give me a device. I have a device in mind. I don't have it sitting with me, but I just need it for some period of time, either to run a manual test or to access and do some debugging. So Device Farm addresses both of those use cases. In automation testing, you can run your tests that you have written using one or more of the popular testing frameworks that we support. Device Farm tries to keep up with a lot of testing frameworks. We also have a mode that I'll show you which lets you run a lot of different testing frameworks that may not be included in the list. So we have a few examples where customers have been able to accomplish that too. And remote access is essentially gives you access to a real device inside a browser, and then you can just interact with it. So imagine you have an emulator running. What if someone told you you get the same emulator experience, but inside a web browser on a real device of your choice? So you say, well, I want a Samsung Galaxy S8, say for example, or a Nexus device. You just get it in the browser. So for those who might have joined on the live stream a little later, so we're talking about Device Farm here. We are talking about how do you leverage the benefits of testing or doing automation testing in the cloud. And so that's where Device Farm comes into picture. So before we deep dive into writing tests and other things, how does automation testing work on Device Farm? I think it's good to have like a high-level overview or just a bird's view of how does this whole flow work. It's pretty simple. You just need 3 things. You already have your app. This could be a native app, a hybrid app, or a pure web application. You don't really even need an app file. So you take that becomes your first input. You can even have a React Native app. We've had sessions in Mobile Weeks for React Native app. It's upcoming technology, so even if you have that app, that also works. So you take that as the first input. Second, you take your test that you may have written using either of the popular testing frameworks. So to name a few, Appium, Calabash, Espresso, XCUI test, UI automation, UI automator. So there's a whole lot, and I'll also cover into how do you choose a testing framework, because you remember we were talking about, well, if you just do a search, like how do you choose it? So you can use a strategy that we see a lot of customers and just industry trends that indicates how do people approach choosing a framework or choosing the right combination of frameworks. So your input number 2 is your tests. Then you upload these two components to device farm, so your app and your test, and you choose the devices. So that's your input number 3. You select which devices do you want to run these tests on. Again, real devices, you can select the entire fleet if you want and run on all of them, and it's going to run in parallel on all of them for you. Once it does that, remember we talked about reports and artifacts. So device farm device farm provides you flexibility. If you wanted to do the reporting, it does a bit of heavy lifting for you and provides like a standardized report. So it says, well, if you had 1,000 tests, it's going to say, okay, show me your 1,000 tests. I'm going to go, I'm going to parse your tests and then individually run each one of your tests, provide logs, videos, screenshots, performance data, all of this so that you can uniquely see how one single test performed. Or you may have already figured out your reporting. You got better with testing framework. Every testing framework provides its own default reports, its own strengths, like you can make a call and get screenshot. So you've already maybe figured that out, and there are a lot of third-party libraries that you can use for reporting. If you have that already figured out and you don't want device farm to do the heavy lifting of test reporting, device farm will give you the flexibility that it will preserve all your reports. It will say, okay, you have it figured out, so you know how to run it, how to get it. Just tell me how you do it, or what's the execution command, the one line that you use to run your test, and I will make sure that you have your reports exactly as how you have it locally. So you have both the options. So that's the high-level overview. Now, as I mentioned earlier, so what are we going to do in the session? So we'll just look at a testing framework selection approach. How do you select a testing framework, right? Then we'll choose one, which is in this case Espresso instrumentation, and I'll tell you why I chose that one. So we'll build some UI tests. So if you've never written a single line of code for testing or don't know anything about mobile testing, you can still work with me and still apply the same flow to any of your existing Android apps, right? So that's the power of Espresso and instrumentation tests. And then you remember the slide where we said we'll upload the app and upload the tests. So we need the test and the app as inputs, right? So we'll see how do you quickly generate those test packages. Really simple, one command. But every testing framework is different. So the artifacts that it produces might be different, like build artifacts. So, and I'll go through that also, like how different testing frameworks might have it. But essentially it comes down to really just one or two commands every time. And device farm has like a lot of good test packaging steps that you just drop a POM file, like a Maven tool file, and run one Maven command, and it packages it for you. So it doesn't expect you to like learn anything about this packaging and other things. It just says, well, just tell me what framework is it, and I'll package it for you. And then we'll run those tests on device farm that we build here, and we'll touch upon then CI/CD integration. Because if you have an end-to-end stuff, and if you say, well, I started with scratch, wrote my UI test, and now I have a CI/CD system that runs on a nightly basis or daily basis, you almost you're in a good state from where you started with those 8 devices sitting on your desk. So, test framework selection approach. So, since we've been working with customers who are primarily mobile testing experts, or their heavily day-to-day activities involve mobile testing, what we've seen is from the trends and general industry data that indicates that it comes down to primarily 3 types of questions, 3 main. That when you say, I want to choose a testing framework, or how do I build a mobile testing team, what it comes down to is, point number 1, do you have a dedicated QA team? Now, why is that important? Because different organizations have different structures, right? Sometimes devs are the one who also write the unit test, the UI test. And if that's the case, they have access to the app source code. They already know how the app functions, and they're the ones writing the test for it, right? So that makes a little bit of difference because now you have the app properties accessible. You sort of have an internal working. So you can write stuff like, internal stub testing, functional testing, and all of those things. But if it's a QA team dedicated, they don't know anything about the app or the source code, right? For them, the app starts as a black box, and they're given the task, well, we have to test this, right? So number one question, do you have a dedicated QA team? And do you have two separate teams that manage maybe Android and iOS, or do you have just one QA team that does both of them? Why is that important? Imagine you have a QA team that said, okay, we're going to test the Android app first. They picked a testing framework that's really specific or their expertise. Like, they said, okay, we'll use Java. Now, they started on that path, and the same QA team is supposed to do iOS. Now, would it be the case that they have to learn a new technology? Like, do I have to learn Swift, Objective-C to test that app? Like, how do you do it, right? That becomes, and then you'll have to develop expertise in both of them. So the other question is, do you have the QA team that does both of them, or you're targeting just one of them? Third, I think I already covered do you have access to the app source code? Now, let's paint a picture here. So there's a dev team says, okay, I have a source code, I'm going to write the tests. What are my options? If they're the ones that are writing the test, the default Android and iOS ecosystem already provide native testing frameworks. So iOS provides XCUI, and Android provides Espresso test, or instrumentation test, as they used to be called. These are testing frameworks provided by the platforms, Android and iOS. They work with the same language. So in Android, you write instrumentation test using Java. And if you're on iOS, you write it using Swift or Objective-C or XCUI test. So it becomes an extension because the whole flow, the architecture, the anatomy of a test like an Espresso or XCUI test is sort of understandable because you're already comfortable with that language. So that becomes choice number one. The other thing is, let's see the other side of the story. Like, you have a QA team. Now, most of the times we see QA teams do both Android and iOS. So it would be nice, right? Like, if a QA team says, well, I'm going to pick a framework that's going to allow me to treat either iOS or Android both as black box, and I'm going to write one test or one framework, and I'm going to test for both of them, and I'm going to only maintain one code repository. So the frameworks that fall in this school of thought are, like, most popular ones are Appium, Calabash, open source frameworks. They provide the benefit that you just use one language binding, and then you can write the test for both Android, iOS. And then every frameworks, tries to provide more features on top of the native one. Like, Appium may have certain calls that the native framework doesn't provide. The catch there you have to be careful, or QA teams have to be careful, is because these are open source frameworks, when a QA team pursues these, let's say Appium was chosen, Appium still builds on top of the tools that maybe iOS or Android provides. So iOS has this XC runners that run on the test, or they use other tools like WebDriver agents that Facebook provide. So they bring a combination of tools to make this seamless for you or simple for you. So the catch there becomes that you still are relying on the open source community or the stable version of that testing framework. So as a general indication that we see from customers is sometimes these frameworks tend to be not as stable day one as the native testing frameworks. So that's a catch. And then so you particularly just consider an error percentage, saying, well, I know that iOS 12 got released. This version is going to be flaky for a while until a stable release comes out. So I have to be careful for that. So that's how those school of thoughts on what testing frameworks to choose go about. So we are going to do Espresso test today for Android. So the reason I chose that is, if you work with a sample app, or most people would have access or want to write an app, even if you don't, if you're QA, if you have the sample app. So it's just simple. It provides a really neat tool called a recorder. So you don't really need to even learn coding or say, okay, how is this test case structured? Of course, it helps always to know what's there and just make changes. But it's really simple. It's really intuitive. So I'll show you how it's done. So let's build a UI test for Android. So first, we need the sample app. I'm just going to use the same app again if you want to work with me. It's the sample Android app that we have. So anything about Android 3.0, Android Studio 3.0, that should be good. So anyone who's on the live stream, if you go to github.com and just search for AWS device farm, sample app Android. I know that's a long string, but I'm giving you the one that's going to bring you the first hit over there. So just git clone that, and that's the app I'm going to work off. Now, so I have this app open over here in Android Studio. So let's just, first let me run the app. So I have an emulator here. I'll run it on that. Let's see. There you go. Emulator opens up. So what is this sample app? This sample app is a native app. It's a hybrid app. It has some web views also. But it's essentially a lot of UI interactions that a typical app could have. So like, it has native components, shows images, scrolling, video, camera, content out of view. So the app is just basically gives you a good idea of how UI interactions could be. So it's a good starting point if you want to write any test. So let me go here to home. Done. Now, espresso test, as I said, is an instrumented test. What is an instrumented test? If you hear the word ever, instrumented test, what does that mean? So instrumented tests are the app and the test, both are separate processes and both execute on the device. So in most testing frameworks, you'll have a client and server model where the device is connected to a host machine, and then you have a server somewhere and it's talking and it's sending commands and the device is responding back. In instrumented test, both the test and the app are executing on the device and they live on the device. So your app becomes like a app file, and that app is talking to a separate app, which is your app under test. That's what instrumented test mean. And XCUI is the same category. So if you say espresso, it's a type of instrumented test, and if you say XCUI, then it's also a type of instrumented test. Appium Calabash, no, because they have their own servers running. In Calabash, it even goes further. It embeds a server inside the app. So you have to drop a server component inside the app, and then that server component relays the UI events that you're telling it to do to the app to achieve the functionality. The catch there is you are testing something that you're not going to release. So you want to be careful on that, on what's your acceptance level. Because if you say, for my test, I embedded a server inside my app, and this looks good, but when you're releasing it, you're removing that server, right? So now your app is slightly different than what you tested it on. So you might want to be careful. We see a lot of times that if you're doing some intensive performance-related test or other things where you're capturing like maybe frame rate, thread count, and other things, you might want to consider that there was a server running in there. So instrumented test. How do you run and record a test? Really simple. Go to the Run menu, and here's a nice option there that says Record Espresso Tests. It will ask you for a target, like where do you want me to record your test? And you just say the emulator, or if you have a real device, you can use that. So what it's going to do, it's going to build the app first. It's going to create the underlying libraries, dependencies. Gradle's going to do the heavy lifting. You don't need to do anything. And then it's going to attach a debugger. There you go. So it showed the message waiting for debugger. Now, you see this, there are two windows. On the left side, there's an emulator. And on the right side, there's a record your test, right? So whatever UI interaction I do, see, it generates an event for that. So when I click on this menu, it says tap image button with content description reference app. Now, how did it know it had to get a content description? It tries to go and take the most unique thing that it finds. So it goes by like ID, maybe index, or maybe if index and ID don't match, then it tries to go with content description. So it recorded an event, right? Now, let's open a page, maybe alert. So if I click on alert, you see that was the 6th option there in the menu. So it picked the child position 6, so that's probably the index. So what are the, any test needs assertions. If you cannot assert, then it's not really much a test, you're just running through it. So let's add an assertion. So let's say that this was, hypothetically speaking, this was a web UI element that was being loaded, right? And you just wanted to see, well, did it fetch it? Is the button present on my app? So you want to add an assertion. So how do you do that? There's a button here called add assertion. So you click on that. So it says dumping UI hierarchy. So what was that? So whenever you write any testing framework, the way it works is you have to uniquely identify the UI elements on the screen. So it takes a snapshot of the screen, says, okay, I know each and every element, and I have the metadata for that, like what's the unique ID, what's the name, what's the comment, what's the description, what's the index uniquely identifying this UI in this whole list, stuff like that. So it takes a snapshot of that, and then basically that's how you identify. So if you were manually writing these tests, that's how you would work off. You'll say, okay, ID number, whatever the name is. In this case, what this recorder does is it lets you select an element. So see that it's creating a red boundary on the button. So if I click on alert, and if you look here on the left side, it says it uniquely identified all those elements that was taken as a snapshot, right? So I'm going to keep that, and I'm going to just say exists, because that's I just want to say whether this button existed. So I'm going to say save assertion, and I'm going to continue doing my tests. So I'm going to click on alert again. So see, it says tap compatible button with text alert, and I'll click on OK. See, tap app compat button with text OK. And then let's save this one test. So I'll say OK. So it will tell me, well, what's the name do you want to give to this test? So I'll say alert test. Now, that's just is asking me to add to Git. I'll say no. Now, if you look at it closely, let's see what it did. So it created a test class alert. It's going to ask me what runner do you want. So instrumented test used to have runners. So you can say instrumentation runner. Right now, by default, the recommended is you use the JUnit4 runner. So all is this stub. So you really don't need to know each and everything of this stub, because you already wrote your test. But let's go through it real quick, because we know the sequence of what we did, right? So let's open the app here, just so that we understand again. So this was the view, right? All I'm saying is, give me an image button, find it with whatever content description, the name was reference app. And if you were to write manually this test, you will have to figure all of this out to uniquely identify the element. And then if it is displayed, perform a click on that, right? So that's one action. So this code snippet that it generated, it just signifies that. Then the same flow again. Give me the view, and give me a navigation drawer fragment. So this is my navigation drawer. And it says, well, the position 6, click on that. So basically, we clicked on this. Then we added an assertion, right? So it again checked the view, said, give me a notification alert button. So it had a unique ID. So that is the notification alert button. And we said, if it's displayed, check. And the check is essentially the assert here. And so that's your assert. And then you click on that. When you click on that, it says, well, in my view, give me a notification alert button with text alert. And that's what we clicked on. And then once it pops up, the same flow again says OK, right? That's it. So that's the stub. So if you were to not use the Espresso recorder, imagine how much time you would just spend like locating the element, and it's like, is it displayed, is it not displayed? Like, what's the position? Did someone change something in the code? It can be a headache, right? So how do you run this test now? So we have the code generated. So to run anything in Android Studio, app, test, anything, you need a configuration, right? So configuration. So you go to here and say edit configuration. Yes, please.
I don't see this device form and AWS.
Uh-huh.
So do I need to install something?
In Android Studio? So the question is that do we need to, so in Android Studio, we don't see AWS device farm. So what we're doing right now is we are just keeping device farm out of picture and just generating tests. So device farm. So there is a way to even have device farm devices show up over here. I will cover that. But for now, we're just doing rudimentary testing. So what if someone didn't have or didn't want to do it from the IDE? They already got the app and test, and still they want to run it on device farm. Right? They're getting a build system, they're getting the build. So what I'm doing is I'm approaching it from how do you write tests from scratch, and then we'll go to the device farm part. So the question is, do you need to install Espresso? So Android Studio comes with Espresso in build, so you don't need to install it on top of it. Yeah. So in any of your apps, so because we use the Espresso recorder, it will add the dependencies in your app file for Espresso. If you were to do it from manually scratch, then the Gradle file will indicate Espresso-related dependencies. So if I Let's see if I can find the right file. Let's see there. So it added the espresso related dependencies over here, right? Yeah. So if you were to not use the espresso recorder, this is what you would have to add, and then basically that's what means that you added espresso. Got it? Does that answer the question? Cool. All right. So where were we? So we were trying to edit a configuration. So we say edit configuration, and then we say this is a type of instrumented test, right? So espresso. So I'll say add instrumented test. Let's call it alert, and the module is app, and then let's target the class that we just generated. So we said alert test, right? And say okay. So it's going to run all test methods in alert class. I'm going to say apply, okay, and let's give it a run on the virtual device. So Gradle's going to do its thing. It's going to install the app. It's going to install the test APK. There you go. And that's the test. It ran, and you can see one test passed. So we wrote a test from scratch. We didn't need to know what is espresso, the stubs, or everything, right? And you can use the same method for any of your existing app. This is really not like a hello world, oh, just sample and you need complex. This is actually the flow a lot of espresso users use because you just need the UI interaction. You can add a search, load, and other calls in there, but that's how you generate UI. Now, so we covered how do you generate tests. Now let's move on to device farm. So let's see here. We generated that, so we need to generate the app. So going back to the slide here, so we needed the app, we need the tests, right? So we need to generate those two files. We wrote the test, we have the APK. How do we generate those? So I'll go to command line terminal. Now, I am inside the root folder of my app. So basically, that's the app that I downloaded from GitHub. And there's only one command here. I say Gradle W, small c, capital C. So it says compile. So it's like compile tests. So that means compile, and then test, and then generate it. So if I just run that command from the root, because this is Android app, it has Gradle build files, and it's going to do the build, and it's going to even run, because we have an emulator connected here, it's going to run the whole test again. It's going to take a while. So while it does that, I have a pre-built file of the same thing, and let's use that. So what happens is, this is what you're going to see. So loft. So under build, let's see. So it's under app, build, and then output, and that's where it generates the two files. APK. So essentially, from your app's root folder, if you look under app, build, oops, sorry about that. So app build outputs APK. So once the Gradle command completes, that's where it's going to have your APK file. Now just a heads up, this sample app also has other instrumentation tests already pre-populated. So it's going to not only run our test, but also other one. Now, moving on to device farm. Now, let's say you have these two APK files. This is your app file. This is your test file that gets generated from the Gradle command. Now, how do you run on device farm? So first, we go to the AWS main console. I'm signed into aws.amazon.com. So device farm runs under mobile services. So we have device farm here. So I click on that. Now, what you see here is the main device farm landing page. So what you see is a card layout. It's just projects. Each card is a project. What are projects? Projects are nothing but collection of test runs. What is a test run? You have your test that you wrote. You selected 10 devices, say, for example. That becomes a test run. So you can have it. It's completely up to you. How do you want to have it? You can have one project for Android, one for iOS, maybe one for CI/CD. So let's create a new project. And let's call it SF Loft. So if you recall, we talked about two things, automated testing, remote access, right? So let's do automated testing first, and I'll come to remote access. So I'll say create a new run. The flow remains the same. I need the app, I need the test, and I need the devices, right? Now, all of these steps that I'm showing, you can achieve this via CLI, via SDK, and we have numerous language bindings. So if you use the AWS SDK, you can use the same AWS SDK to do device farm related stuff. And for those who might have joined a little late on the live stream, so we've covered writing UI tests so far, and now we are trying to go on and run those UI tests on device farm. So first I upload my app. So if you see here, there's a distinction, two tabs, two buttons basically. So one is for native and hybrid, and the other one is pure web application. So if your app just runs in Chrome browser or Safari, you just select that. So I'll upload and give it the APK file that our Gradle process generated. So let's see, GitHub, Loft, and then give it the app file. Now, while it uploads the file, it's doing a bunch of things in the background. See, it does a pre-processing of the metadata. So it looks into your app metadata and tries to catch some errors early on. Like, let's say you thought, well, my app is supposed to run on all the devices in the world. It ran on my desk. It should be all fine. So it tries, if you see there, it captures the target SDK, minimum SDK. So like, if you selected like 200 devices and your app maybe not even be built for some SDK version. So it's going to catch this early on. And even when you select devices, it's going to tell, hey, compatibility issue, your app wasn't built for this. That's why it looks at the metadata. And then you can see it can capture like screen size resolutions, what's the version of the app. So step number 1, complete. Step number 2, tests. So we wrote instrumentation tests for Android. Now this list is only specific to Android. So if you see here, we wrote tests, but what if you didn't write any test? You're like, I just want a quick sanity check. I don't want to write even my test. Just tell me if it launches and if the first page works fine, that's good enough for me. So we have 2 types of tests to cover that. One's called built-in fuzz and the other one's built-in explorer. So fuzz, what it does is, fuzz works on the scope of the device. So it's going to say, well, I'm going to launch your app, and I'm going to throw random UI events on the device and your app. So it's random. So it might, once it opens its app, it might immediately kill it, or maybe click on any UI button that it sees. Maybe it will swipe down the notification bar. It's just, it's a monkey runner. It just tries to act like a monkey. The other one is Explorer. So it works within the scope of your app. It explores your app. So it says, okay, I see 5 links. I'm going to click on one. Whatever page opens, it tries to go as deep as possible. So it's going to explore your app as much as possible. So you can just select those, and Device Farm will do the heavy lifting for you. It's going to say, well, let me look at your app and do this stuff. But we generated the APK file for our test, and Espresso was an instrumentation test. So we'll upload that. So again, when we upload this, it's again going to do a little bit of pre-processing. It's going to look at your test, whether the file is in correct format, whether it's whether the test classes are correct, whether there's a runner indicated. Now, here's where the default distinction comes. So if you look here, since long time, Device Farm had just one mode of execution, which was like, you remember the detail reports that you uploaded the app. Let's say, okay, it had 100 apps. I'm going to give you each result for each of those. And that's what it is reflected here as a standard mode. But we recently, 2 months ago, launched a new mode, which is the custom environment, which is how do we bring priority to your local execution? Because you may have a complex setup that downloads some dependencies, does some commands on the device, generates a reports, maybe emails it, maybe uploads it to S3, stuff like that you may already have a pretty complex process figured out in-house. So the recommended way there is you use custom environment. So what is custom environment? It gives you the ability to completely customize the host execution environment to which the device is connected. So you can issue like ADB commands to it on the fly. You can tell it to retry a test. Think of it this way. It's driven by a test spec file. What is a test spec file? It's a YAML extension file. But simplistically speaking, it's a shell script. If you were to initialize an environment, say, here are the shell commands that I'm issuing that run my test, set up the environment, do everything, that's what that file is. So if you look at it really quick, so there's a lot that might be seeming to happen here, but it's essentially just comments. So it just has 4 test phases, which is pre-install. If you want to install something, put the commands here. So you may have something like, npm install maybe Node.js, say for example. So that goes in here. If you had a pre-test, maybe you have to set the class path, or maybe you have to initialize an environment variable, or maybe change the Java version, stuff like that. So you do that here. Your test command is actually what command do you use to trigger your test. So if you look at this command here, all it's doing is saying ADB shell, instrument, blah, 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 blah. Where did it come from? So if I go back to my thing here, you see that? Well, it looks similar to this command that Android Studio used to trigger the test. So what device farm does is it does the heavy lifting of figuring out the command for you for each testing framework. So what we expect is for most customers, they don't need to even touch this file. If you're using the standard way, you just use the default file and it will just go. And post-test, if you had some reports, if you want to like email your reports or have some post-test processing, you can issue those commands here. Artifacts, you may be generating video files, log files, some other binary data, and you want them to be accessible after your test is complete. So that goes into artifact section. Sure. Yeah, so the question is that, does the test have access to Bluetooth sensors or other sensors on the device, right? Yeah, so device farm doesn't block access to any of those hardware features that you might have, so Bluetooth, your camera. There's some context there. So let's say Bluetooth and your radios are pretty straightforward. They're either on or off. But if you turn on Bluetooth and if the expectation is you had two devices and they're going to talk and see each other on the Bluetooth, there's really no saying where those two devices might be located. Right? So you can, of course, turn them on, turn them off, but there's really no guarantee that they're going to see anything. And since we have the isolation, they're not going to even see any other device. As far as camera goes, you will get the access to the camera, it will open it, but you're going to get a black screen. You're not going to get anything. So even if you record a video and expect like, oh, maybe, there's really nothing. It's just black. It's a black hole. Yeah. So even if you use some other testing framework, where it accesses those sensors. It's going to not prevent your access, but you have to be just careful what are you looking. Because if you're looking for like, can I get a camera, have a QR code in front of it and like take a picture, those advanced cases are not supported today. Cool. So let's just use the default file. And there are other few configuration items here. If you have like an internal test server that you need to hit, we have a feature called VPC. So essentially you can have your dedicated devices and they can talk to your internal test servers or non-public IP address servers. So there's a whole feature that supports that use case. You can also skip your app re-signing. What is that? When you upload an app, we re-sign the app. Why do we do that? Because the devices are managed and maintained by device farm. So we need a reliable way to actually install and remove your apps because where AWS security is and always will be our top priority. We want to make sure that when customer A comes in, runs their test, and then stops the session, customer B, if they get the same instance, they shouldn't have the same app or test artifacts, right? So we need to re-sign and make sure that we can control those devices. But if you have dedicated devices, which is an offering where device farm says, if you want some dedicated devices, we're going to procure them for you, and then they're only available for you. So in that case, the devices, the UDIDs. We're not going to re-sign. We're going to say, well, we'll skip re-signing because these are your devices. Yeah, so the question is that does the customer provide the private devices? No. So the way it works is the customer tells the device farm that I want these devices, these instances, and device farm goes out and then procures them. Yes, we had one more question. No, so is the question.
That's a little confusing because you're not sure you're paying for what amount of time. Right?
Yeah.
You have to have slots horizontally for parallel.
Got it. So the difference, so the question is that is it the same as slots at the private devices? So what's the difference there? So slots think about it as like a concurrency number. So slots tell you, well, if you pay $250 per month per slot, that's the number. So if you had like 5 slots, you can run on 5 devices in parallel. If you had 20, you can run on 20 devices in parallel. And they're not tied to a make or model. So you can choose any device at any given point, but it's going to run on 20 at a time, maximum. Now, private devices, and slots apply only to public devices. So if you say like you see an iPhone 10 running iOS 11, that means that, iOS, we may have multiple instances of that device type behind the scene, and there's really no guarantee which instance do you get. You'll get a working instance, that's the guarantee. Private devices, you actually know the instance. So because we actually buy exclusive hardware for you, and then that gets reflected in your account, and you can see, well, this is my device. So if you had 100 private devices, your concurrency becomes 100. But the pricing is different. You pay for the flat monthly cost for private device. So depending on the retail cost of the device, it falls in a bracket, and then that's what you get charged.
Do I have to have at least one slot to run on device farm?
Yeah, so the question is, do you need to have at least one slot to run? No. Even if you don't have a slot, you go metered. So if you didn't have a slot, but if you need unlimited, if you want to keep your cost, then yes, you need at least one slot. But then it will run only on one device at a time. So that's whereas on metered, by default, if you just logged in today and ran, it will run on 5 devices in parallel. Yeah. Cool. Right. Yep, question.
We have an online question.
Yes.
Is it possible to run detox, automated end-to-end test for React Native in device farm?
All right. So the question is, can we run detox test for a React Native? So I have not personally validated that, but here's the theory. I have validated running React Native apps with espresso tests, and they have worked pretty fine. So I use a React Native app, use the same espresso testing framework. So if you use custom mode, the answer should be yes, because as long as you know the dependencies that you need, so if detox, you know how you run detox, you know how to download the framework and have all your test package, you can download that. Device farm's not going to interfere. If you know, like, okay, this command line executes the detox test, and the only requirement is it should have a device connected to the host machine, it will run it. It doesn't care whether it's React Native or no. So the short answer, pending validation, is yes, you should be able to. I don't see any reason. It may not be the out of the box. We don't support it out of the box. But I can certainly see as a workaround, until we officially support it, that you could run it. All right. So moving on. Then there's other configuration. You can enable or disable video recording app performance capture. So go to next. Now, so here's the power of device farm. You see a list of devices, right? So third step, selection of devices. You see a list of devices, and these are like basically curated pool. So the one that you see right now is just a pool that's dictated by 3 factors. What are customers running on? What are the most popular devices in the market? And what are customers asking for? And then depending on that, that pool keeps on changing. So right now, the data indicates that these are the 5 more popular Android devices that customers are using. But not everyone would want to use this device, right? You may have your own specific needs. So what do? You create a new device pool. And now you see, here's the real power of device farm, where you have all these devices, different Android devices on all the OS versions that you can run your test on in the public fleet. So if I scroll, if you see carefully, there are some devices that have a lock symbol. Those are the private devices. So they appear with your public devices. So you may have some dedicated devices. So you can mix and match also. You can have a set of private devices on the side and then public. So let's quickly form a device pool. Let's say I want a OS version 6, maybe an LG device, LG, there you go. Maybe I want an OS 8, Samsung maybe, there you go, S9. Maybe an HTC device running Android 5, there you go. Maybe a really old 4, and maybe Motorola. There you go, Moto G. Let's give this a name, save the device pool. There you go. So those are the devices I'm going to run my test on. I'll say next. So there are some configuration items here you can see. So you can have extra data. If your app or test needs some data to be present on the device, or while your test executes, you can upload that. You may have other dependent apps that need to be installed on the device while the test is running. You can give those other apps here. Imagine your app, you click a button, Facebook opens. You may need that interaction, so you can install those apps. Radio states, you can tell it whether the Wi-Fi, Bluetooth, GPS, NFC, if supported on the device, it should be turned on or off when the test starts. Device location, imagine cap sharing apps where it behaves differently when it's near a certain latitude and longitude or a certain location. You can give it the location and it will mock it on the device. Path to your files on the host machines. If you are generating your own reports, your own special data, binary files, you can tell it where device farm could go and fetch it from the host machine or the device when the test is complete. You can also change the language on the device. So if the device supports that language, we will change it for you. Here's the network profile. So imagine one of the key cases is, how does your app behave when there's a bad network? Or you just walk out and the network deteriorates. So you can create a profile. So we have pre-populated profile which says, well, 3G good, 3G lossy, bad Wi-Fi. So you can use one of those profiles and it gets applied to the network to which the device is connected. Or if you're adventurous, you can create your own profile. Then I say next. This is just a review page. Now I'll say confirm and start. Now, one of the key benefits, because we selected custom environment, is firstly, it's going to go and look for a working instance of these 4 device types that I selected, right? And then once it finds a working instance, it's going to trigger my test. So it already found 3 devices. So if I go here, what it's going to do is it's going to run some preliminary checks on the device. So like, is there a Wi-Fi on the device? Is there internet connectivity? Is there a stray pop-up on the device? Does it have the correct OS version? Because you can imagine cases like these when your test automation starts running. If you have a pop-up, it's just going to stop there. And it's like, okay, and you're going to be just chasing down pop-up issues rather than your app issues. So it's going to do those checks. It also checks for malware. It also checks whether the device is clean from previous run. And once the test starts, it's going to show you the live log streaming on the right side. And on the left side, it's going to show you an actual video of the test in action. So once, it's going to show what test is actually executing. So we should be able to see our alert test over here. Now, to save time here, let me show you a run that we already executed. So let's pick a device here. And once the test is complete, it's going to show you, so this is an Explorer test, not a good example. Let me go back. Pick this one, pick that. There you go. So it shows the video of the device. You see that's actually captures the entire test. As I mentioned, it has other tests apart from just our alert test. Then this is the live log streaming that you're going to see while the test is executing. Pretty standard log. These are not device farm logs. These are what any testing framework would generate. You also get performance data. How was your CPU performing while the test was executing? How was the memory? How was the thread count? So you can correlate, like, maybe your app froze at some point in time here. Like, okay, at 1:47 something happened. So you can correlate that data over here. That, okay, at that point, how was my app behaving at 1:47? Was there a spike? And you get all of your test artifacts. So, whatever the standard test framework produces, you'll get all of that. In addition, you'll get your video, your logcat, and your TCP dump that device farm captures for you. So I do also want to show the standard mode, the distinction. So if you had like a test in standard mode, this is how it's going to look. So the same thing, but device farm does the reporting for you. So it says, here are the unique failures that I found. And if you open one of these, it's going to tell you, well, it failed on these 2 devices. So if you click on those, it takes you directly to the test, shows you the stack trace and the video of the failure. So this was the simplification of reports that I was talking. And if I go on a device, it's going to say, show me my entire test classes that I may have run. So this is the heavy lifting of reporting that I was telling you, that if you don't have your reports, it's going to parse individual tests. And if I just click on maybe any alert test, then it's going to show me how many test methods I had. So this is the device farm doing the whole thing. I think we are out of time here. So that's what I wanted to cover. We also have a Jenkins plugin for CI/CD integration. We do have another session tomorrow. I'm going to cover that in depth tomorrow. But for simplicity, if you have a Jenkins instance running, it's simply a few clicks. You can download an official plugin that's loaded. And the plugin has exactly the console steps that we had. Select a project, select a device. You save that once, and you can apply it to any existing build system. And it's going to just say, well, this Jenkins system builds my app. I'm just going to give it to the plugin, and the plugin is going to schedule the test for me. That's the flow how Jenkins plugin works. I think that's what I had in the time we have. Any questions?
So, if you need test the camera, then there's no way to test it.
The question is, if we have tests that can run, but there's no way to test.
Like,
Oh, camera test.
Yeah,
Yeah.
Let's say we put some recognition app. So
Yeah.
we need to, recognize something.
Yeah.
Then in that case, there's no way to test.
Correct. Yeah, that's a restriction. And the key point there is because of the security that the high bar that we hold ourselves to for the device, if we don't have a system that will maybe place something physically moving in front of the device. Unfortunately, we don't have that today. But I can do see, the way customers have achieved these use cases are, I've seen that they do stubbing of like the QR code. So if a test actually wants a camera scan, sure, it's not going to do the exact camera thing. I mean, we have customers who've tried to click pictures, on that, but all it does is a flash with black screen. What they do is at that point they induce a stub of the QR code, and then the step after that is, it's pretty automated. But I do understand the restriction. Unfortunately, we haven't cracked that yet. How do we have that? Yeah. All right. How do you handle crashes? Yeah, good question. So question is, how do you handle crashes? So if there's a crash report, device farm will capture the default crash report. So let's see if we do have a crash report. Oh, you know what? Maybe the Explorer did crash the app. Let's see. It does that a lot of time. There you go. Let's look. Did it crash? Oh, you know what? I have an example. So short answer is device farm will capture the crash application report. So when an app crashes, it generates a default report, right? You can access those in Xcode, Android Studio. It fetches those reports. Let me show you an example, then it will be more clear. So if I go, where was I? Here, and show you the standard mode execution. That one. That does have a test that actually crashes the app intentionally. Do I have it? Fixtures, maybe here. Or not this one. Trying to find a good example. But it will fetch all the standardized crash report logs that you expect in an IDE to show up. Like where's my, dump of the crash report log. So it will show those up in the artifact section here as crash application report. Yeah. Cool. Any other questions? All right then. Well, thank you very much in the audience, and thank you everyone who's on the live stream. If you have any questions from the live stream, let us know on AWS Twitch at Amazon.com. And thank you for everyone for hanging around till the last session and being patient.